Hello students, this is a software sim8085 used to simulate 8085 programs. So here you can type your assembly language program. So generally when you do in lab, you usually start from the address 4100 something like that, because our lab kit has a user memory starting from 4100 to 5FFF. So here it is a simulation software. We can start from 1 itself. So you can see there is a main SME. Just go to this website and you can see in the starting there are registers like A/PSW, so that shows accumulator value and PSW values, then BC register pair value, then DE, HL, SP, PC. So once you execute a program, we can see the status of those registers. Also the status of the flags can be seen here. So let me type a program. So here I'm going to type binary to BCD conversion. Okay, so to give a comment in assembly language, we start with a semicolon. So whatever you write in a single line after semicolon will be considered as a comment. So I'm going to give the heading here, binary to BCD conversion. Okay, so this program is written in a call stack manner, a call return manner. So we are going to use a subroutine in this program. Okay, so to use a subroutine, first of all we need to initialize the stack pointer. So for the first step, we'll initialize stack pointer. You can write the programs either in small letters or capital letters, it doesn't matter. Okay, so for convenience I'll use capital letter. LHI SP stack pointer slash, I'm going to give stack pointer value 4FFF. Okay, 4FFH. So that will take it as a hexadecimal. Then my input location in HL pair, so LSIH comma, let it be 4300. First number is in accumulator, then increment the HL pair. Okay, then MVI. So here what we are going to do, we give an 8-bit input number in binary, that is in hexadecimal. We need to convert it into BCD. So BCD we'll be taking units place, tens place and hundreds place separately. So we call it a unpacked BCD. So to take hundreds place first, we'll be dividing that number with 100. So 100 in hexadecimal means 64H. Okay, then I'll call the number program subroutine that will divide this number with 100. Okay, so when you return from that program, I'll have the hundreds place. Then I will write the next code to divide it with 10. So next I'll give in register 10 means 0A. Then final remainder will be in accumulator. Okay, so the final answer, every time I'll be saving the answer in the subroutine itself. Okay, the final remainder I am saying from this code, that is MOV M, A, then HLT. Okay, so here we have to see one thing, that is I'm using the statement call bin. Okay, I missed one here. There's one more call bin. So bin is a label. So I need to write the subroutine starting with the label bin. Okay, so next step I'm going to write the subroutine. So when you give label here, you write the label name, then give a semicolon to indicate it's a label. Okay, then you write the program starting at the subroutine. So first step will be I'm taking MVI M, F. So I need to clear the first register where I had to save the value. So first number input is given at 4300 and the answer should come at 4301. I need hundreds value, 4302 I need tens place, and 4303 I need units place. Okay, so what I will do to clear, there are many methods we can clear the number. So one method I'm using here is just write the value FF to that particular register and then increment it by 1, that is FF plus 1 hexadecimal 100 will be the answer. So that 00 will be in that particular location. So I'm going to increment. Now I wrote FF. So if I increment this register by 1 INR M, so now 4301 will be cleared. Then we need to divide the number by 100. So division is done by repeated subtraction. So I'm going to subtract B. So right now first step, the B will be 64H the first call case. So the number will be subtracted, number will be in accumulator, so accumulator minus 100, it will do one subtraction. And if there is no carry, means there is no borrow, that means the answer will be positive. Okay, so if okay, so JNC next means if there is no carry, it must repeat the subtraction process. So here we are dividing by repeated subtraction. So suppose say the hundreds place value is 2, something in 200. Okay, so once you in the first case we'll increment INRM, then the memory value will be 0. First subtraction will give 100, 200 minus 100 will be 100, so that answer will be positive number. So the positive number means there is no borrow, so there is no carry, then it will jump to next. So again it will increment M by 1. So now M value will be 1, 0 plus 1 1, then again it will subtract. So once it subtracts, suppose if I have given the input number as FF, then that corresponds to 255 in decimal. So one subtraction, it will give 155, then INRM will be having a 1. So second subtraction, 155 minus 100 will be 55. The answer is positive, so there is no carry, no borrow, so it will again jump to next. So INRM will increment 1 plus 1, it will give 2. So the answer I have 2. Then that is my final answer. Okay, so next subtraction, it will be 55 minus 100, so that is a negative number, that will indicate a borrow, so there is a carry, so there is the jump instruction will not be executed since there is a carry. So it will go to next step. In next step we will add the B register value to accumulator. So accumulator now has an answer corresponding to 55 minus 100, that is minus 45, right? So minus 45 plus 100 should give 55. So the remaining tens and units place number we need it back in accumulator, so that's why we'll add B. Then we'll increment the HL pair by 1, so that I can store the tens place in next location. So now 4301 will be incremented to 4302. Okay, then we'll return to the main program. So after returning to main program, the second before the second call bin, we have MVI B, 0A. So next program will be executed to find the tens place value. So in a similar way, repeated subtraction will be done and tens place number will be saved in 4302. So before return, we'll increment it to 4303, and the final answer will be remainder will be there in accumulator. So that accumulator will be remainder value will be moved to 4303. That's the end of program. So I have typed the entire program now. Now let me run this program. Okay, so you can see if you can either take it in a desktop mode. You can see the comments here how to write the code. So code editor is this one, just click on next. It will show the compile button. So this is compile button. Okay, run button, then step button, stop execution button, reset everything button. Okay, so to go a particular location, just type the address there and then click on the next on the keyboard. Okay, so to go to that location, so it's better to use the mobile mode. If you're using a mobile, then don't use desktop mode, because then editing will be difficult. So you just to double tap on that particular location. So I need to give input at 4300. So this is my 4300 value. So by default it is 0. I have to edit that. Let me give FE. So FE, the answer should be 254. So I should get 3 results, 02, 05 and 04. Okay, so that should be my answer, and it should come at 4301, 4302 and 4303. So okay, so now I have given my input. Now let me compile the program and run the program. So I have okay, so I executed the program. So you can see the answer is here, 4301, there is 02, there is my hundreds place, and tens place is 05 and units place is 04. Okay, so to stop execution you can just stop, click on that square button. Okay, so you can edit the value, you can give some other input, you can check that. Okay, so let me check for 64. The answer should be 100. Okay, just run the program, the second button. Okay, you can see the answer. The answer is 100, so only hundreds place will be 01, remaining will be 00. Okay.